Okay, so in last video, we talked about we could use the sum of the variances for the sampling distributions to estimate the standard error for our sampling distribution of the mean difference. But we got a problem if our sample sizes are very different from each other. So in other words, we didn't do any weighing work. We didn't take the sample size, the different sample sizes into consideration. So here in this slide, I'm going to talk about a better way to estimate the standard error when we have very different sample sizes. So here is the equation how to calculate or how to have a better estimate of the variance for the sampling distribution of the mean difference. We call it a weighted estimate of the variance. And here is the equation here. We call this variance the pooled variance because we are doing some weighing work. We want to take the sample size into consideration. So here we have this kind of degree of freedom for X group and also the degree of freedom for Y group. So we can see that we are giving this X group's variance different weight from the variance for Y group, and then divided by the degree of freedom for this overall for these two samples. Again, for this equation, you don't need to remember it. I'll give you guys this equation in the exam. So get back to our sexual partner example, we simply plug in the numbers. So we have 10 participants for the X group -1, and we have this the standard deviation for men and also standard deviation for women. And this gives us a better estimate of the variance of the sample distribution, which is 14.91. And then we're gonna calculate this standard error for this sample distribution of the mean difference here. And here is the equation how to calculate that. Still, we want to give different weight for different sample size. So we want to first divide the pooled variance by the sample size of men and do the same thing for women. Okay, and then we plug in all the numbers, and this gives us a better estimate of the t-value for our observed mean difference, which is 1.41. And then we go back to the previous thing we just did, which is step 4. We check the t-table for the critical t-value given this degree of freedom, significance level, and also two-tailed test design. And the degree of freedom for this case remains same, right? Positive and negative 2.086. And we want to compare this better estimate of t-value with this critical t-value. Still, this obtained t-value is smaller than this one, so we are gonna return the null hypothesis, claim that men and women do not significantly differ in their lifetime sexual partner number. And this is our final and accurate conclusion. I'm not gonna give you guys bad news anymore, okay? So that is the whole thing we want to, if we want to do an independent t-test. The same logic with all the previous tests, but the only difference is we're gonna use different calculation. We want to find out the standard error here, okay? And here is the practice time. Still, let's say your nerdy instructor wonders whether her stats class makes her students more anxious. So by the end of this semester, your instructor, me, I collected 2 samples of data. So one sample, I'm gonna distribute a survey among you guys, 23 students from my 2750 class. So I'm gonna ask you guys, to what extent do you feel, panic, anxious, stressed out after this semester? At the same time, I'm also gonna recruit 30 students from music apprehension class in our Webster University. So 2 separate groups, and both groups, they were assessed for their stress level ranging from 0 to 10 point. I have the data below. So my question is, I'm gonna ask you guys to test the hypothesis whether my stats class makes the students more anxious or not. Okay, so this is the data here. Here is the 23 students from our stats class, and this is your stress level ranging from 0 to 10. I have calculated the mean for these 23 people here, and also the variance, standard deviation, and sample size is 23. And for another group, we have 13 people here. I also calculated the mean for this group, the variance, the standard deviation here, and sample size is 30. So please note that there is a big difference in terms of the sample sizes here. So you got to use the pooled variance to estimate a standard error. Okay, I have listed all the equations or the formulas in previous slides. So please do this practice and upload your work, and I'm gonna kind of check your answer, and I'll probably talk about the answers, the solution in next week's class. So in next video, I'm going to talk about how to, calculate how to do this independent t-test in R. And on the last video, I'm going to give you guys a summary about all the tests we have learned so far, the similarities, the differences between these tests.